Let's clarify any doubt with Avogadro's constant. So the value of it is 6.02 times 10 to the 23. Often you're given it, but you will end up remembering it because you see it so often. What it tells us, okay, so the definition of it is the number of particles in 1 mole of substance. So number of particles in 1 mole of substance. So it's important to understand that particles, it could be the number of electrons, but also the number of molecules, or maybe just the number of atoms or ions. So this number of particles can be molecules. It could be atoms. It could be ions, or it could even be electrons. Okay, so if we do an example, sodium chloride. If I ask you, in 1 mole of sodium chloride, how many sodium plus ions are present? We always need to think about the ratio, because remember, the numbers next to the atoms or in a chemical equation before the whole molecule, it gives us the ratio. So what we know is that for each molecule of sodium chloride, there is inside only 1 sodium ion, because there is no balancing number. So how many sodium ions are present? This magic number, because is 1 mole. So in 1 mole of sodium chloride, you have a 6.02 times 10 to the 23 number of Na plus ions. Okay. But what if we think about oxygen? If we have 1 mole of oxygen, how many oxygen atoms, and let's make it look like this, these are our oxygen, or better, molecule. How many oxygen molecules would you have? That magic number, times 10 to the 23 molecules. But what if I tell you how many oxygen atoms? So this is molecules, but what about atoms? Again, you look at that concept of ratio. For each oxygen molecule, how many oxygen do you have in it? Well, you have that number. For each molecule, you have 1 oxygen. Okay. Actually, sorry, 1 to 2, because you have double the number, don't you? So if you have this number of molecules, guess how many atoms of oxygen will you have? Just picture, you have, for each molecule, you have that split into 2 oxygen atoms. You have double this amount. So this seems a very big number, but think about it. 1 mole is this new unit that you use in chemistry that represented these many numbers of atoms. Okay. The reason is that you cannot really measure it in grams. Yeah, that's not very representative. Okay. But is all relative to this amount of particles, yeah, in that specific amount of substance. Okay, because if you have a 6.02 times 10 to the 23 moles, atoms of oxygen, well, they have a different mass compared to the same amount of sodium chloride. So this explains how we can still compare quantities, but without thinking about mass, which is how we normally measure things. Okay, hope that clarifies. Important to have clear the concept of ratio. But well, actually, very last thing, you can actually work out an equation to calculate the number of particles, right? Because let me give you the beautiful triangle. So if we want to calculate the number of particles in a substance, we simply need, so the number of particles, we use moles times the Avogadro's constant. Okay, and this would give us how many particles we have. Think about the example I did before. If we had 2 moles of oxygen atoms in one oxygen molecule, well, we have to time this by 2. Here, we worked it out with logic, but there is an equation that you can remember from that. The important thing is that you do know the constant and a little bit the meaning of it.